G'day everyone, how you going? We're here at my school, just handing back a test that we did the other day. It's all about functions, cubics, y squared equals x, those sort of functions, circle functions. So a lot of learning in here that we can do, so even if the mark wasn't great, use it as an opportunity for learning. So what did we start up with? The non-calc section here. So we got given this polynomial, obviously it's a cubic, and we were told that when x is equal to 1, the answer is 0. It wanted us to show that. So all we do is take the 1, substitute it into the equation, and you can see how I've shown that comes to be 0 here. A couple of key points here. One, it says show, so don't just write the last line. That's not showing it. And secondly is this one over here. Don't write 0 equals 0. Or anything. 5 equals 5, 3 equals 3. You're not showing or proving anything. Right? You've got to start with the equation and show that the value of the function when x equals 1 is equal to 0. That's what you've been asked to show. This is meaningless. Be careful about that. Lots of people write that. If you see that in your working, you're not on track there. You've got the wrong idea. Hence find the other zeros. Because we know, up above there, we know that 1 is a solution to it. That means x minus 1 is a factor of it, meaning that we can divide, synthetic division, put the 1 here, and therefore when we divide that into, these are the coefficients of the original, we end up with this here. Now this 0 is important, because that's saying that x minus 1 divides exactly into it. If that came up with anything but 0, we'd be in a world of trouble there. So we take that, that's our answer to dividing 1 in, or x minus 1 as a factor. That then becomes there. And if you wanted to, you could find another 0 of that and then do the same thing. Or you can look at this and say, well, hang on, what are the factors that give me minus 6? And which ones of those will add together to give minus 1? And you can see minus 3 and plus 2, they will multiply to get minus 6. Add them together, we'll get our minus 1. So there we go. These are the other solutions. Now, key point here. I sort of disagree. It's saying here, hence find the other zeros. Now, if it's a 0, that must mean that y equals 0 or f of x equals 0. They're X-intercepts. Now, the other teacher has said, Miss Walmerans has said, well, actually, when waste marking, and she's done it more recently than me, this would not be accepted because it's not a coordinate. I kind of disagree because it's inherent in the question that by finding a 0, we're finding the root of the equation or where it crosses over the x-intercept, x-axis, and therefore y is 0. But I'll take that advice, so I'm going to pay that. I'm going to pay that. But I'm going to say to you from now on, if it asks for zeros or x-intercepts or y-intercepts, answer as a coordinate. Okay? The only time you would answer like this is if it asked you to solve the equation, and then you can just give an answer. Okay? So solving, this would be okay. Anything else, write a coordinate, or write a coordinate all the time. You're kind of never wrong that way. All right? Again, I kind of disagree, but I'll take on board the advice. Expand and simplify shouldn't have been too much of a problem there. We're really just multiplying out. Multiply 2 of them together and then multiply that in. Doesn't matter what order you do them in. Think of this as 2 times 3 times 4. If you multiply 3 by 4 and then multiply it by 2, or 2 by 3 and then multiply it by 4, doesn't really matter. You get to the same answer. So multiply 2 of them together, then multiply the third one in. You should have come up to this. Just 2 marks for that. That shouldn't have been too hard. Question number 3. So these are our 1 on x graphs or our reciprocal graphs. If it was just that, it'd be our standard reciprocal graph. Alright? So that would be if we had an axis here, that would give you a bit here and a bit there. But we've got a minus 3. Now remember, when we change the x value, we're shifting it left and right, and we're doing the opposite to what this might suggest. So this is actually moving it 3 units to the right, not 3 to the left. Okay? If you had a number out the end, that's affecting the y coordinate, so whatever it is there is what's happening. So if it was plus 5 at the end, it'd move the thing up. Minus 5, move it down. This here kind of does the opposite. The way I like to explain it is that really this minus 3 is moving the axes 3 units to the left. Or you can pick the graph up and move it 3 to the right, but the end result's the same. So find the domain of f of x. So there was 1 mark for showing that you knew the notation and how to set it up, and 1 mark for actually getting the right things. So this is saying, curly bracket says I'm giving you a set of numbers of x such that x is from the set of real numbers and x cannot equal 3. Now for those just doing methods, the whole why do we have to write just real numbers, the specialist people will understand we've got another set of numbers, complex numbers that we can use. So just understand we've got to do this to just keep it in real numbers, and then this is the thing that the graph won't allow us to have happen. The next one for the range, very similar notation, but because we hadn't moved the graph up or down at all, we were still having that 0, the x-axis that we couldn't cross. Okay. Determine the equation of the vertical asymptote. Well, that really was just restating the domain in a slightly different way, because the vertical asymptote of these graphs is the value that the graph can't cross, and therefore is just that one right there. So it's just x equals 3. And for what values is x less than 0? Well, if we remember, we've got a graph here. Originally, it would have been here and here, but then we moved it 3 units across to the right, didn't we? So this part's all above the axis, but this part is all below the axis, isn't it? Below the x-axis. So it's just a rewording of this. Now, if you wrote less than 3, you got the mark, because it can't equal 3. That's our vertical asymptote, isn't it? So it's only numbers less than 3. I gave you 1 mark for this, but really, less than 3, the question was asking less than 0, not equal to 0 or undefined. So really less than, not less than or equal to. Question 4. So this should have been a fairly easy 4 marks. We're looking for graphs that are functions versus ones that are relationships. Easiest way to look at it is the vertical line test. So here, wherever I put a vertical line, it only cuts the graph once. It's a function. Here, it's going to cut twice, isn't it? Not a function. Other way to explain it, one x value will give me many y values. That's another reason why it won't be a function. And then down here, very, very similar idea. Not a function, a function. Okay? 4 marks there, 1 mark for each. Now these ones then were asking about understanding the graph and writing a domain or range for the graph. The first one here on the left is a y squared equals x type graph. So again, the notation. And we've got set of real numbers. X is greater than or equal to minus 3 because you can see easier on your graph. This lines up with minus 3. And because this graph goes forever and continually gets wider and wider and wider, really there is no restriction on the y's. There's nothing that can't happen for a y value. So here we just say it's the set of real numbers, leave it at that. Nothing more needed. Over here, a little bit more tricky, we had to know what this looked like. So this is going to be our circle graph. Remember, this is really r squared. So therefore this is 4 squared, that's our radius. So we end up with this. Maybe I should have put a mark here saying these were 4, that probably would have been ideal. So really our x values can only be from -4 to +4. And our y values from -4 to +4. So they're virtually the same, just substituting x for y. And I've just spotted, I've made a mistake there. That shouldn't be x, that should be y, shouldn't it? Because I'm talking about the range there. Yeah. So this should be y. I've got a bit lazy there. Obviously I looked above and went, yeah, it's going to be the same. I'll just swap them over and I missed one. So that should be y there, not x. But hopefully you can figure that out and see that. I'll tidy that up before I post these. The next two, very similar. Let's just do the one on the left. This is very similar to the one above, just that it's a parabola now rather than a y squared equals x. So for the x components, the domain, any value is possible. And for the range, it's from here, which is at -2 and up. So y is greater than or equal to -2. So that makes sense, very similar to the previous one. This one, I'll just squeeze it all on. So we've got this graph here. Now it's a y equals the square root. So we've only got 1/2 of the graph. We've only got this part. We don't have the other part there because we'd have to start with y squared equals x to get that other part. So this is only half of it. This says move 3 units to the right. This moves 3 units down, hence why I noted that mark there. So 1 mark for that part of the graph. And then the follow through here. Once you've got the graph, it's not really so bad to work out the domain and range. Greater than 3 or equal to 3 for the domain, and y is greater than or equal to -1 for the range. Alright, question 6. Oops, let me catch up. Okay, so drawing a sketch of the following. Now this is where, especially on the right here, this is a little bit different. I'll get there in a minute. This is just a circle, and this is telling me what I'm doing with the x coordinate. I'm moving 2 units to the right. The y coordinate 3 units to the left, so that's where the centre of my circle is going. And again, remember r squared, so r is 3. So you can see here, I've moved 2 to the right, I've moved 3 down, and the radius is 3. There was 1 mark for the style, so basically recognising that I knew it was going to be a circle, and 1 mark for getting the location of it correct. Over there on the right hand side, the marking's the same idea, but this is where we've started here with something y squared here. Now you could multiply all this out like a binomial expansion. You're not really going to get anywhere. What you want to recognise, if I take the square root here and I take the square root there, now that's where you've got to think, hang on, I get plus and minus the square root of x. So you can see I've rearranged it there. I've taken the square root of both sides, plus and minus x, and then I've moved this 1 over to get that. So it's a standard y squared equals x graph, but move down 1. So hence why we get this kind of idea here at -1. And again, we've got 1 mark for the location, 1 mark for the style. You notice how I did really well getting a nice curve here, but not so much here? What I should have done is just turn my page around, upside down, to get the other curve. When you're writing it this way, your hand moves really nicely. When you're trying to do the other one, you it's more difficult to do, but if you turn your page around, it's a nice easy way. So that's the trick for, I should have done it there, that's the trick for getting nice smooth curves when you do it. So that's the end of our non-calc section. So now we've got the calc section here to go. So question number 7, a function is defined by that, so it's a quadratic, fairly simple. Determining expression for this, well, adding something on the end is just picking the whole thing up, moving it down. So we really just add 5 on the end. Get this one. Now that's pretty nice. It says factorise your function. Well, it factorises pretty neatly. And determine the x-intercepts. Now, again, I would pay this, but again, my note earlier, it asks for x-intercepts. Well, by logic, y is going to be 0, but let's write these as -3, 0 and 1, 0, so that you're specifying a coordinate for it. All right. We go along a little bit further. We say that, well, what does this f of x plus 5 represent? We're translating it 5 units up. All right. Key things being 5 and the direction. All right. But the whole word is really, the whole thing really translated 5 units up is good. Write an expanded expression for f of 2x. Now, lots of people made a mistake here. Whenever we have the value of the function at any point, 2, 5, 7, 9, 2x, whatever, we take that and put it into the equation wherever x is. Right? So lots of people didn't know what to do with that first part, but regardless what x is, if x is 5, you put 5 in these spots. If x is 3, you put it in here. If x is 2x, you put it in here. So you just put whatever is in those brackets straight in, and then we recognise that 2x squared is 4x squared, isn't it? Because it's 2x times 2x. Okay, so we end up with this one. That was a key error. 2 marks for that. 1 mark was really for knowing what to do with it, and 1 mark for the simplification. And then what is that going to do? That 2x, that's going to be dilation parallel to the x-axis, scale factor of 1/2. Now all of that's really necessary. A few people, especially in the other class, said a dilation on the x-axis. I don't like that wording, because that sort of suggests that you only do something on the x-axis. Parallel to the x-axis says I'm taking the whole thing and squishing it in. Yeah?
Is that the same as dilating it of a scale factor of 2 parallel to the y-axis?
Yes, it will be.
I
Yes.
didn't get any marks.
Okay, we'll follow that up. Yeah, because you can stretch it this way, it'll have the same impact as doing that. Yes, it will. Yep. The next one, question number 8. Now, I gave you a whole lot of information here. Everything was here you needed. We've got a function, cubic, so we're thinking 2 turning points probably, a couple of x-intercepts maybe. Coordinates of the turning points are, oh there we go, 2 turning points, so we know we've got 2 turning points. And we can also factorise it to this. So that's giving you your x-intercepts, isn't it? X-intercept at 1 and minus 2. Now that one's important because we've got an x-intercept and a turning point happening at the same point. So it must be coming to the axis and turning on the axis. So we put all that information together and we end up with this one. Turning point and x-intercept, turning point, x-intercept. The marks were 1 for the shape, 1 for your behaviour as it went to infinity, and then 1 mark for each of the key points. And it did ask, have a read, it did ask, on the axis below, clearly sketch, clearly indicating axis intercepts and turning points. So that's, put a coordinate to it. Make sure you say to the marker, hey, this is where it is. So you had to itemise those parts. Now, whenever you do a graph, you should really put arrowheads on because they go on infinitely, don't they? So really arrowheads. And if you're worried about saying, oh yeah, but how do I know how big to do it? Roughly what you would do, see the end of the axis. If you draw a shape, which will be kind of a circle or an oval around, that's about the area you should go to. So you can see if I kind of did this, I'm kind of just there, and here I'm a little bit away, but I'm approaching that. So that gives you the indication of where you need to be.
Yeah.
Last question over the page. This was a great question. I really like this question. I stole it from New South Wales, I think it was, or Victorian paper. They had it a little bit different. I modified it. I thought it was great. Part of a polynomial function has a degree of 3. So it's got to be a cubic, doesn't it?
Yeah.
Can't be a quadratic. It's got to be a cubic.
Yeah.
Part of the graph near the point with the coordinate 2, 0 is shown below. Now this 0.1, it didn't really matter about that. We couldn't do anything actually with that. I know you might think we could, but it just tells me that it turns on the axis. So that means the turning point and a point of intersection have to be the same there, don't they? So that idea is telling me that in my cubic, when I factorise it, 2 of the brackets are going to be the same. Because if I just have 1 bracket, that's where it crosses through the axis. If I have 2 brackets, then that's this situation. So therefore, I've got to have in here, I've got to have x minus 2 squared. That's how I'll get that. Okay? Now then I also realised that, okay, I don't know whether this is a positive or a negative quadratic, cubic, because it could be doing this, could go up, and then go down again. So that could be how it is, or it could be coming up, going down, and up again. So it could be a positive one like that, or it could be a negative one like that. I don't know that, I can't tell that from here, I haven't got enough information. Then it's a bit of knocking the ones out that are not going to work. First of all, this one. It's going to be a cubic, because I've got x squared and x, so I'm okay there. But this would give an intersection or a turning point of minus 2, wouldn't it? We're at plus 2 here. So this is not going to work for me. This one's a quartic, because look, I've got an x squared from there, and an x squared from there. So that's a quartic, x to the power of 4. So that's not going to be, because the question said it was a power of 3. Degree of 3. This one's only quadratic. So while that could be right, and if the question didn't say cubic, then this could be the one. But it said cubic, so I'm not there. This one's okay, I'll come back to that. This one is not going to be any good either, because notice there's only one x-intercept there. There's no other part to it. So this one, if that was the graph for it, it would come up here, it would go flatten out right there at 2 and then go up again. So that's what this one would look like. So it can't be that one. So I'm left with these 2. Okay? Now it did say circle which of the following equations. So that was your hint, so maybe there's more than one. This one is cubic, x-intercept of 2. I'm good there. This is cubic, has an x-intercept of 2. I'm good there. Alright? And then it says, well, okay, from your answers above, determine the other solutions to it. Well, if it was this one, then I've already got this as a solution. It's this part that needs to be the solution. And you can see what I've done. And if it was the one over there, then this part's got to be the other solution. So it's going to be x equals 1, x equals 0. So a really good question, that one. I quite like that question. I'm not suggesting that you would like it as much. For part B, I did notice when people were doing part B, they weren't very good at communicating what they were doing. All right? Hopefully you see here I'm saying if I'm taking this equation. So I'm telling the marker, hey, I'm working with this equation. Here it is. Then the intercept has to be when x minus 1 equals 0. This part. Therefore I solve. And same on this one. So try and step through your mathematics as much as you can. Really good test, some good results there. Thanks very much. Use it as a way of learning. Look back through, do it again, watch the video again. Hopefully this helps you out. Catch you later.